for day 2 of literal equations, we are going to focus on formulas. So the first formula that we're going to work on is from standard to slope-intercept form, but it doesn't really matter the name. We just want to practice moving everything, and we're going to see it more in next unit. And the next one is just looking at formulas, because a lot of the times they're going to ask you to manipulate formulas and move stuff around. So in our first set, when we're steps to converting standard form to slope-intercept form, and I just put slope-intercept form here for you. These are what standard form looks like, but again, not super important, just getting used to moving the variables around. So our first step always says to move the x and that coefficient, which is what we always need to do to get y by itself. Just like on day 1, we always had to do inverse operations. So to move this guy over, since it's a positive, I need to subtract 3x on both sides. 2y equals, and for the sake of this assignment, you're going to put negative 3x in the front and plus 6. Okay, because it's technically y equals mx plus b, you want the x before that number. Again, not a big deal, just get used to moving it in the front. Now you always want to multiply or divide by the coefficient in front of y, so since it's 2 times y, I need to divide everything on both sides by 2. Y equals, I'm going to leave this as negative 3x over 2, and 6 divided by 2 is just 3. So that's the final form, and that's y equals mx plus b. Your slope, your y-intercept. That probably sounds familiar from 8th grade. Alright, same thing for next one. If you want to try it by yourself, go ahead. If not, work with me. I want to always move the x first, so since it's a positive, I'm subtracting it. Leaving negative 3y equals negative 2x plus 9, since it's a positive 9. Again, since it's multiplication here, I'm dividing both sides by negative 3. Y equals, since there's 2 negative here, they cancel, and it's just going to be 2 over 3x. 9 divided by negative 3 is a negative 3. Leaving that as my final answer. Okay, the next few are just looking at formulas. You have to make sure you're looking at the variable they want you to solve for. So there's going to be a couple variables in each problem. So if you notice, example 3 and 4 are exactly the same, except for this one wants you to solve for r, and this one wants you to solve for h. So we're going to start over here first. We want to solve for r. That squared is connected to the r. So I want to move everything else first. I am going to move the half first. So to move the half, I need to multiply both sides by 2, and it might be easier if I rewrite it. Multiply both sides by 2 over 1. That cancels everything out over here, leaving 2a equals pi r squared h. I'm still solving for r. So since it says pi times r squared times h, I need to divide both sides by pi, and while I'm at it, I can divide that side by h also. You can do it in 2 separate steps if you want. I'm just going to throw it all into one. Okay, just like yesterday, the inverse of squaring is square rooting, so I need to square root both sides, and I'm running out of room, so I'm just going to throw it over here. By doing that, these cancel, and my final answer is r equals square root of 2a over pi h. Alright, so my next one, I'm solving the same exact way, except I'm looking for h instead. Again, whenever there's a fraction, I'm going to try to get rid of that first if I can, which I'm allowed to. So I'm going to do both sides by 2, canceling out over here. 2a equals pi r squared h. Since I'm solving for h, that squared there doesn't matter. Okay, it's just going to stay in the problem. I don't have to get rid of it. Pi times r squared times h. I can divide both sides by pi, and just like the last one, I'm trying to get rid of that r squared. So I'm going to do that also. So now since h is all by itself, I am done. Okay, next one is a perimeter formula for a rectangle. P equals 2 times the length plus 2 times the width, and we're solving for L. So 2 is connected to that L, so I can't touch that 2 yet because there's that plus 2W. So I need to subtract the 2W first, leaving P minus 2W equals 2L. And I always make my L look like that so it doesn't look like a 1. And then from there, I need to divide both sides by 2. Now that's an acceptable answer. You might also see them break it up like this. So P minus 2W, there's a 2 over here and a 2 over here. So I'm just going to square this one so you know that is acceptable and I will take it. But do you notice there's 2 2's here? So they can technically cancel, leaving P over 2 minus W equals L. So if there was a select all that applied, make sure you're looking to simplify everything if you possibly can. All right, the last one is one of my favorite formulas. It's Pythagorean theorem for solving for side lengths of right triangles. I want to solve for A. There's a squared connected to that A, so we're going to have to square root it at some point. Again, I need to get rid of that B squared, so I need to subtract it to the other side. Square root it to get rid of that square. Now you need to be careful. I cannot get rid of the squareds here because there's a subtraction sign separating them. I can do it over here because it's just A squared, the square root of it. There's a subtraction sign here, so I cannot get rid of those 2 squareds. So that is my final answer.